Hello DevPro, here's Renzo Nucitelli talking, and today we are going to build a CrossFit judge using computer vision provided by HoboFlow. Right now you may be asking yourself, what is a CrossFit judge and what is computer vision? But better than trying to explain it to you in words, I want to show you a demonstration. So let me zoom out in here what you're seeing. So this is the main application, something that is going to count the exercise repetitions, what you call on CrossFit back squat, which is my favorite exercise in CrossFit. So I'm going to take my keyboard with me. Let me put it here, and I'm going to restart this one, and you are going to check on the rest of the video. I'm going to start on this position, right? I'm going to do a back squat. In fact, it's only a squat. I don't have the bar with me, but well, let's see it. So let me refresh the page. So you can see that now I have the start in there, the person start, because I'm not, on my feet, like in a right way, in a 90 angle degrees with the ground. You have in there 0 reps, which means repetition, because I didn't have done the complete exercise. And now I'm going to try and start the exercise. So first I need to be straight up. So we are going to see that now the computer vision was able to check that I'm up, and now I can start the exercise. When I bend my knee and I have bent, the system was able to check on that. I start the descending phase. And to complete the descending phase, you need to really go down until your feet is parallel to the ground. So this is something that it's an invalid move for a CrossFit judge. You need really to go to the ground, otherwise it's not going to count as an exercise repetition. Once you're hitting the ground, so you are on the down position, so you can start the ascending phase. So I'm going to do that right now, and you can see the ascending phase. But if you don't go straight up and go down again, it not count as a repetition. You need to really go up, see, and now you have the first repetition. Of course, when you are doing the exercise, you are not intending to fail, like I did this on purpose. You are going to do that. So hope, the second one, hope, whoop. Come on, I'm up. Thank you, the second repetition. Yeah, the gods of the demonstration are ruthless, but you can see it's counting on the position in there. So, now that I'm warmed up, let's check a little bit on the code and the path that I have gone through on this application, because my main goal is to show to you that this application may seem hard, and I thought that on the beginning of this project, but I spent like 3 days from learning from grounding up the computer vision and put that in place to show you this demonstration. So I'm going to share my learning journey with you so you can have a grasp of what you can do with this tool. So let me close this one and let's start to check a little bit of code. Well, before code, let me show you the main architecture that I have used on this project. So basically I had the web browser that you just saw in there. So I'm sending frames to a Flask server written in Python. So I send the frame of the exercise from my webcam to the Flask web server. It's going to send the frame to the inference server. That's a tool that is from HoboFlow. HoboFlow, the inference server, is going to use an API key where you can grab it on the HoboFlow once you create an account. It's going to grab a model, a computer model that can make the inference, as the name says. So it's going to grab a model that you can indicate on the project. It's going to return this model, and from now on, it's going to return predictions to the Flask application, so it can use to enhance the image and show the final image that I just saw to you with the data of the repetitions, classifying objects, and so on. Okay, so this is the main application, and just to be clear, the only part that I knew before starting this project, it was this first part. I'm a web developer, so I know about front-end applications. I know about back-end applications, but I knew nothing about inference, computer vision, and stuff like that. And I was really impressed about I was able to do in a short period of time using RoboFlow to provide me with those predictions. So, well, when I started this project to make the CrossFit Judge, I thought about start with only one exercise, so slicing the problem in there, because we have a bunch of exercises on CrossFit, so we need to start with one. But first, I needed to understand what is a model and what is inference and stuff like that. Well, basically, the model is going to capture the image and try to make the predictions and classifications, but to do that, it needs what in data science is called a data set. And what is a data set for computer vision is a collection of pictures that we are going to present to your model and say, okay, this is something that I want to classify. And I followed the basically tutorial in here, and you can do the same with the RoboFlow, where they are going to teach you how to create the data sets online in there too. It's really amazing. And you can see it here, the first project, it's to be able to classify glow sticks, knowing what is the bottom of a glow stick and its top, and it's a showcase of that. And I followed this tutorial and presented on this project, where we have all the code for this project that you saw running. It's here, and for the learning as well. So here I write up the things that I learned, even fixing some codes that I needed to fix to work in the way that I was running this project. But on my first try, this is the prediction. It was not able to label the glow stick, but I use only 5 images for that. And I knew that for a good data set, you need a reasonable amount of data, and we are going to see one that worked. And with 8 images, I had some classification, but unfortunately, I got like 3 different classifications for only one glow stick. So at this point, what I thought was, okay, I got what a data set is, but if I want to do a back squat, judge, is going to be a very hard work. I was thinking about filming myself on the gym, make the exercise. In fact, I have done a little bit of that because I thought about training a model to be able to detect the full exercise, but I have a grasp that it would be a lot of work doing that for my own. But the good thing is that, RoboFlow has what they call universe.roboflow.com, where you have public datasets. And what have I done? I have just searched for squat. I was wanting, right? And got all these results that you can see in here. And this one that has 1,000 and here. So this one has 1,300 1,313 images from our squat. And I opened it, checked that has a lot of stuff, a lot of images in there, where I can see here the image. So I get that, it's classified in squat up and squat down with a bunch of images. So the good thing is that I thought, okay, since it's public, how can I use it? So what I have done, I'm going to be back in here on my page on projects. Okay, so I forked that project since it's public. It's very similar to if you are use it to GitHub. I forked the script and use it RoboFlow to train it, and it's only a matter of clicking in here. So I have the training from RoboFlow itself. So I trained this model that has this ID in here. Okay, so nice. I have a trained model. How can I test it to check if it's going to provide me the results that I want for the application that I want to build? So for that, RoboFlow have another very cool, and I'm going to copy it in here. They have something really cool which is called workflows, where you can use to make your application, but also to test it. And let me check where person with key points. This one, it seems done, person with key points. So okay, this is the saved version, but I'm going to start from fresh again. So when you create an workflow, it's going to create this one where you can use blocks to test your application. Here you have the input where you can input a file to test. So I have this one, and I'm going to show you. I found on the Google an image of someone doing, an squat. But check that, you cannot see if it's on the ascending phase or the descending phase, but for sure it's on the middle phase for the CrossFit. And it would not be considered down. You would need to go further down to be considered a valid movement, right? So, okay, I have my input in here, and let's try a first model. And that was the time that I needed to study a little bit to understand the difference among the models. I believe that people from data science probably are very used to it, but since I was and I am a web developer, I was not. So by checking by studying, I checked that what I want, it was an object detection model on this case in here, and I can select it. Okay, create a model in rep. No, it was not that what I have done. Come back, please. Loading again. Please, gods of demonstrations, let me remove this. This will be the final result. I didn't want you to see that, but that it's going to be the final result. So let's remove all the stuff in here, and let's start from a template. No, not the template, but a model. In the public models, I'm going to use this one. In YOLO, it goes for you only look once, and it's good for object detection. So I'm going to start. I started with this one, and in here, I have some parameters, and one of them is that I can change the data model in here for the one that I have just show you. The squat. This one, let me show you, is exactly this one. You can copy the idea of your model that I have trained in here, so you can paste and select this model. So right now it's going to be an object detection, but it's going to use the data set for the squat that I have just presented to you, but well, I don't know why. Select model, yeah, so now it's here. And once you have your model, you can test it on the workflow by itself. So let's make in here a test workflow. Let's run it. I had the input in here. Why is not using it? Well, doesn't matter. I'm going to upload this again. Test workflow, run it. Let's check the result. So let's see. Let me open the image. This is the image from the back squat. And you can see it's saying that I squat up, and this was a little bit confusing to me because as you can see the name that I provided, it's on the middle of the face, but the model has a confidence of 67-68% that it's a squat up, and that could be an issue for my application. So but you know, in here it's kind of difficult also to check what I'm saying to you. So on the workflows, you have some blocks that helps you to debug your model visually, and I'm going to show you it. So here on visualization, you can use the bounding box visualization that's going to draw a box around detected objects, and you can use also the label, and that was I spent some time learning that I was not aware on the beginning of this project. So label visualization. So now let's test our workflow again. Let's see the results. And the good thing about bounding box visualization and label visualization, I hope that we can see it in here right now. So you can see that the model was able to identify a person in here and identify it with this label squat up. So I thought, wow, maybe it would not be the solution for my project. And I tried with another image that I'm going to show you right now. I searched for the squat middle 2, where the lady is a little bit below the first one to try. And okay, let's use it. Let's run it again and let's see the results. And you see on the predictions, it was even a little bit in doubt about what she's doing, because the model has 8% confidence that is a squat up, but also a 42 confidence that is a squat down. So, and we have a threshold for that, so this is considered a squat down. So once I saw that, I thought, okay, I'm not going to be able to use this data set because it's not a valid movement for CrossFit, right? So it's considering only in the states of down and up, and it's not considered the right thresholds that I wanted for my application. So I thought, okay, maybe I will need to do the data sets. This one, it's pretty at least promising, but having to label 1,000 images to make it right, it would be a lot of work that would not be possible to do on only 3 days of a proof of concept. So I started to dig around, checking for other models in there, and I removed this model in here and decided only to use the regular one. The regular one is going to be able only to say that it's a person. I can say, let's run it, and you are going to see that this one is going only to classify, okay, this is a person, and that's the only thing that is going to do, but I can at least use that, right? So see the class of the classification, so this is a person, and I can use that, and I use it on my final project, but I needed something else to say about to make the calculations about a right back squat movement on CrossFit, right? Well, what I have done after searching around is that I needed another model that can show you the parts of the body, all the parts of the body. So on this class filter, you can add a filter, because if you have other objects that this model can classify. So I'm going to filter to only person. But what I'm going to do, I'm going to add a new model in here. And this time I'm going to use the key point detection model. And I don't know why it was created on this side. I didn't want that on the beginning, and it's not going to work. Let's see if it's not going to work again as the first time that I was trying in training for this presentation. Okay, because the output of label visualization is not valid for the key point detection. It needs, you know, the input from here, from the image. So what I have done, that was, I didn't found much of documentation about that, but I checked that, you know, on the advanced editor, you have some inputs in here and say images from input webcam. I thought, okay, maybe I can use that to make the result that I want in here. So I can came in here and say, okay, so the image that I'm going to take is from this one. So you can see the change in here. So from the webcam, and the model that I want, model ID, steps model 1, okay. Let me see, model 1, okay. I have the two outputs in here, but the input model identifier, let me check. What can I do? Because I wanted this input come directly from here. So model 1 predictions, model predictions, I have it in here, but I would like to have the inputs directly in there. Let me see the advanced, class filter, model ID, images, and what I have in here, step.model.id, model ID. It's not this one. What it says in model? YOLO. Oh, okay. Let's back to default editor. I'm going to change the model. Let unlink and select again the YOLO. I don't know if the pronunciation is YOLO. Probably not. This is some of from the Brazilian Portuguese on this video, right? But anyway, let's test this workflow. I'm going to add for visualization so you can have a grasp of what it's going to do. I'm going to add this key point visualization so we can see on the outputs what I want with this. Let's check, let's run, check if it will work. And well, you can see here, you know, the key point visualization is going to provide me the visualizations on the legs, you know, the arms, eyes, and all the positions. And you can see on the output that those positions are there, you know. Let's see the predictions. It's a person with you can see here nose, left eye, right eye with the positions in here, so left ear and so on. And what I was really interested, it was, you know, left knee. With left knee, what I was thinking about if I can have the angle of the knee so I can calculate a perfect back squat based on the knee. And that's what, in fact, what I have done, and I'm going to show you a little bit. Let's see a little bit of code, because talk is cheap. Show me the code. So let's see the person key point detector. And right now, what I wanted on this, let's check the code. I mean, I'm going to show you. No, I'm going to show you right now. And what I wanted to see was a video, right? A person. On the beginning, I was thinking about recording a video with the exercise and being classified in making another video with the classification of those exercises. So I have gone here on video. Oh, sorry, in fact, on deploying. And I checked that for video, you have a different code so you can run, you know, a pipeline. Because for an image, you can only send the image and that's fine. You have a result if it's only an static image that you can save. But for videos, you are going to send a lot of frames of the video, right? So for that, they have the experimental code, which is called RoboFlow Inference Pipeline, where we are going to init an workflow, passing the API key, the workspace, the ID that exactly this one that it's on the URL in here, the video reference that can be a path to a video, or 0 if you want to use your webcam for that, for real-time processing, and you start and join. So this is the base code that I use it to make the, let's see here on the board, let me increase the font size, and you can see this is the code that I have done. I have only used my knowledge from DevWeb to not show you my API key on this video, so it's something that you need to keep secret and not put in your code repository. So I have done that, but you check that the configuration is exactly the same, but I changed the path for a video that I have done on my Gene doing a back squat front, but oh, it's wrong, right? The name is wrong. It's with an X array. Glad that I saw that. And what it's going to do is going to pass all this video file that I have in here, and it's going to process it using MySync function, that is this one. When you check the code for MySync, so it's basically, you know, getting the results that we saw in there, getting the key points for the left rib, the left knee, and the left ankle. So I'm only considering the left part of the bod. Maybe I could improve it and have it from both, but that was enough. And from these key points, I was able to, in fact, I was not able, but I asked ChatGPT to calculate the angle for me. I could do that for myself, but well, why not doing that using the AUI, right? When I'm using RoboFlow, it's based on AUI. Why not using ChatGPT to make the code also? So it helped me providing the angle, the function, the angle from here. Oh, sorry. Let's check, and base it on the angle that I have. Okay. Based on the angle that I have, I calculate the states of the knee, and I defined 3 different states because it's static. Or you are in the down angle, if your angle is less than, and let's see this value in here, you know, 7.3. How have I come with those numbers? I have used the workflow, right? Put in the image that I consider a good bottom position of the back squat, and check what would be the angle that would be a good threshold for that. So 73 degrees for the down angle, and more than the 170 degrees for being considered up. I don't know why my shortcut is not working in here. Okay, now it worked. So you can see if it's less, then I'm going to return the down state. If it's bigger, I'm going to return the up state, and otherwise I'm going to consider the middle one. So that's the basic states that we are going to have to the knee. And from the state of your knee, I can calculate the state of the back squat. I have defined those 2 global variables. One with the squat state. I defined 5 different states for the squat, which are the start, when you are not, you know, up, you are on the start, just on the beginning, and that's the reason that I initiated it in here. So I have the start state, the up state, that we can go from the start state. When you are straight up, you are up. When you start descending, I define the descending state. When you are down and we reach the threshold of 73 degrees, you are going to be on the down state. when we go up again, you're going to be on the ascending state. So in this way, I know if the person is going up or going down. It depends on the state. And after the ascending state, if you go to the up state, if your knee angle goes for more than 170 degrees, you're going to be on the up state. That's been done for all the positions. I have put some prints in here so you can check the results on the console. And based on that, I just put the text in there. I draw the box. I changed the colors in there. You saw the dict with the different colors. If you want to change the colors, you can do it in here using RGB colors. So for each state, I have a different color. And let me see what more I have done. Okay, you can see that I got the box. I decided the color based on the squat state in here. I draw the rectangle around the person, and to define what text to put, I put person and the squat state that we saw on the beginning of this presentation, right? And let's check how it works. I'm going to stop my local web server in here that's running. Let's run this code for the Hanzo Jean back squat front. Remember, it's on here. Let's see if it's going to produce the results. So it's reaching the inference database that is installed and running on my computer, reaching the model that I have defined on the workflow. So I don't know if you are hearing, but it's processing, even because it's using, my GPUs to do that. And let's see. Let's see if it's going to start. Come on, come on, come on. Of course, on the presentation, it would take more time. Let's see. I don't know if it's because maybe because I'm filming. This one is not. Oh, of course. Maybe because my screen record. Let's see. Oh, it finished it. But strange. I didn't saw the prints in there. But well, the output is here. Let's check it. But since I'm working with 8SL, I have copied only to my downloads folder on Hanzo Jean back squat side front. Oh, I have probably overread my original video. Let's see the downloads. This one with this time. Let's see how it was processed. Oh no, this is the side. It's not the right one. Let's classify by modification date. Oh, strange. What's the name? Jean back squat side front. It was this one. This output is not good. Why? Let me. Strange. I just tested it. Let's try with the Hanzo Jean back squat side. The strange thing is that I would hope seeing the prints in here, and I'm not seeing that. That's strange. Where's some with key points? Let's see. Maybe because I changed the model. Maybe. Because it's not printing anything. Yeah. I have changed the model, but let me run. Well, let me show you. I believe that I have some results in here. That was the one of the results when I was doing that, you know, on the side of it. I have tried, and you can see the repetitions, and that what I was able to do. And after I have done that, I discovered that on HoboFlow you can not only using the building blocks, but you can also create your own with Python code. So the next version that what I have done, you see that it's pretty similar to the next one. I just removed the visualization because I don't need the visualizations for the processing. I just need the data. And if you can check in here, I have created, and you can create that. You can add a block and create a custom Python block. I have done that. And I just extracted all those codes that we have just saw in here. You know, check the angle between points that I had in there. So I defined the output to be a knee angle. So this way I have as output the knee angle here. I have inserted the knee state function in here that I have in there. Remember the 73 and the 170 degrees for the up state. So I have extracted to this block. I have even put the squat state, and it worked for videos, but on the HoboFlow documentation, they say that you need to take care because those blocks are running on AWS Lambda functions that can be overridden anytime. So what this means? What this means is that I'm using global variables to be the state in here, but they can be reset at any time. What would, you know, create undesirable effects? Imagine that you have to do 50 repetitions and you have done already 40, but because of, I don't know, a new deployment is going to get back to 0 repetitions. I believe that people would be very angry with this kind of result, right? And what I was not able to do, and I tried, it was having a block to generate the video by itself. Because if I have the completed video, I could just put on the web application, right? Uploading a video file or sending the images in frames from my webcam to GService and getting back the video data. But the fact is that, you know, even if you check on deployment, you'll see that for images, you even have an API and you can roast your service within HoboFlow in this address. But if you go on videos, they don't have this option right now. It's experimental, the things with the video. So I had only the images if I wanted to use the HoboFlow service. So one more option would be running and deploying with the inference servers that I have done here, and I intend to do that. But I wanted have the real-time application because, okay, for the open phase of CrossFit Games, you could upload a video. But if you are doing the exercises, it would be nice to have the real-time response so you can get to know, as I have done on the presentations, to check if you have done the exercise right, you know, on the right way, and it's being counted, right? So what I have on the last version based code that I'm going to show you is the web application version based on the back squat. Oh, and by the way, this is the code for the back squat. You can see that it's very similar to the one, but without the calculation of the knee state, knee angles, and stuff like that. I didn't need it, so this code is much more simpler than this one where I have to calculate everything. Well, anyway, so the last version, it was the web application. Keep in mind that I know the good practice about web application, but since this is a POC, I have done all the code, including the front-end code on the file, but even put the HTML code in here, you can see that it's less than 200 lines of code to have this result. This, for me, it was amazing. So let's check what I'm doing here. So I have a HTML page. I'm starting a video using my camera. I'm using a canvas to display the image that I'm going to get back after the detection. So here I have the data about the processed string with the number of repetitions, the state of the back squat that we have, and also the knee angle, because I was debugging to check if the knee angle was working, right? And I have a JavaScript just starting the squat state as start and squat haps with 0. And what I have done, I kept the state on the web, on the page itself. So several people could, access the page and have their accounts on there. And also because the way I'm doing that, and I'm going to show you, let's see. The way I'm doing that, you can see the function send frame. So I'm sending images to the server to be processed and sending together with it the data about it. Let's see, you see, I send the squat state, the squat wraps, so the server can, based on this data, calculate the new squat state and if it's a repetition or not. And after get the result, I update the elements in here, the visual elements as well. So for the next time that we are going to send the next frame, I get these updated values that I have in here if it's a valid transition. And what I have done is only, setting an interval and calling send frame every 200 milliseconds, which is 5 frames per second, which was enough. If you increase it, maybe you are going to have a better result, but if you increase it too much, you are going to flow your web servers with requests. 5 frames per second, it was enough for this one. And let's check the backend code. So I have only the index to render the HTML page. I have on process frame, I have to adjust my code to use images instead of videos in here. So I'm just, you can see, requesting, getting the frame, getting the previous squat state, printing it, getting the squat wraps, the value of that. I'm decoding the image from base 64. I'm going to encode that with image color. I'm running the workflow with this image that I just received in here. In here, I get the result from the processed image. I get the knee angle, the knee state as well, and I calculate the new state and the increment, if it's going to increment or not, the number of repetitions, and I update squat reps based on this value. So if the knee angle is valid, what I'm going to do is basically using the old code that put the box, the labels in there, and that was it. And that's the version where, let me show you. I'm just downloaded the inference code that's from HoboFlow, and it's open source. Inference GitHub. So I just downloaded, cloned this repository, and I'm just running here, not doing anything fancy. Here's the command, like inference server start --dev. So this is running in my computer. And finally, I'm running, oh no, sorry, this is the inference. I want now the CrossFit Judge. Yeah, so this is the final result that I show you on the beginning of the video, accessing the web page. Let's go back in there, starting the application and have the wraps. You can see that when my body is not fully on the screen, we have those, values. It's trying to find the value anchors, and I could increment on this one to be a product ready, but for a POC, it worked as intended. Well, this code is all on GitHub. This is the result on the web application. Well, this code is all on GitHub. So as I told you before, what I was really impressed is that took me like 3 days from going from not knowing computer vision, and HoboFlow made it possible. And at the beginning of the project, I thought that I was, too ambitious on my project, because it was not only about processing static images. I wanted the movement of it. It make it, of course, a little bit hard, but I was impressed by the way that the tool was able to make possible going from my idea to the application. And that to me, it was like blowing my mind, because right now we are in an age of people use LLMs, so AI using with LLMs, and what I see with the big opportunity, and I see people using a lot of LLMs to make new applications based on this new interface. Like nowadays, because of the LLMs and that they can interpret natural language, people can do bots like, and the only interface is through WhatsApp, where people are going to interact with your application, only send natural language, and the system is going to be able to respond in the natural language. So in the same way, this project opened my mind about what can be done even more than that, with not only natural language, but with vision. And we humans, we are very visual animals, right? And what can be done, and we have a bunch of examples on the HoboFlow itself. But before checking the examples, I was wonder those examples without even seeing that. You can have diagnosis on the medical field, and you can see here on the index, I don't know, banking, to be able to quantify money. An example that I saw in there, like you have the coins, the visual of the coins, and you have an automatic quanting quantities of that. You can use that on agriculture, and I'm from Brazil. Can you imagine like checking that, okay, you need to use more you need to put more water on this part of your farm. You need to remove more water because you are able to check through visualization what's going on. And with object detection, I don't know, the sky is the limit. So that was the reason that I just made this video, even without having a proper studio where I'm using to do my video, because I was so motivated, and I hope that this motivation can motivate you as well to do your application. So try HoboFlow out. Let me see what you think. You can drop some messages in here on this video. If you have some doubt, maybe I can help you as well. Okay? Thank you very much for watching this video. I hope that you can do a lot of very nice computer vision applications from now on. Bye bye.